A proposition about odd numbers, and I'm going to rewrite this congruence in a probably an easier format. Oops, a to the fourth. Already making mistakes here. Eraser. Okay, a to the fourth. This is an equivalent way of restating this congruence. A to the fourth minus 1 is equal to 16m, where m is just some other integer, okay? So again, these things are equivalent. A to the fourth congruent to 1 mod 16 means a to the fourth minus 1 is a multiple of that, and a multiple of 16, excuse me. Another way of saying this is that 16 divides. In other words, you could also characterize this as that 16 divides the quantity. I've seen people a little sloppy about this. A to the fourth minus 1, parenthetically. Okay, it could be ambiguous if you didn't put the parentheses, right? So again, like 3 different ways to state what we mean by congruence. Okay, again, 3 ways. This is kind of a common way. It's kind of an equation way of talking about it. This is more of an algebraic way, and then this is just number theoretic way where this vertical bar means divides. 16 divides a to the fourth minus 1. Now, a concrete example right here would be 3 to the fourth. 3 to the fourth. 3 is an odd number, right? 3 to the fourth minus 1. 3 to the fourth is 81. 81 minus 1 is 80. And so this would be 16. And I'll put a dot here, a big dot here, y'all, to connote multiplication, 16m. Okay. Or it would be 16 times 5 in this case, sorry. 16 times 5, right? 16 times 5 is 80. 3 to the fourth minus 1 is 80. And so we know it's true for the first one, the first non-trivial odd number. It's true for 1 also. 1 minus 1 is 0, and anything divides 0, right? Okay, but it also works for 5 if you want to check that. So anyway, what we're going to prove here, this statement right here is completely equivalent to this statement right here. So it makes sense to expand out a to the fourth. Now this part right here is time consuming. You can use the binomial theorem to do this, but this part could take you 5 or 10 minutes to do it without making mistakes. It's hard, you know. But anyway, I omitted that work, but we can use the binomial theorem to prove this expansion 2k plus 1 raised to the fourth power. Okay, now you can see that when you subtract 1, it's just going to chop off this 1 right here, and you're left with this statement right here, okay? And it turns out factoring out 8 is a good idea because we are trying to show it's a multiple of 16, right? We're trying to show that a to the fourth minus 1 is a multiple of 16. And so factoring out 8 makes sense because if we can show that this part is even, we'll be done, right? If this part is even, you're going to have a times 2 times something, right? 8 times 2 times something, which would be 16 times something, right? Okay, so it's very clear that if k is even, everything inside here would be even if k is even, right? An even number raised to any power is even, and you have the 3 here, but again, if k is even, you have an even number times an odd number, which is certainly even. So this is trivial right here. Now, odd's a little bit more work. This is the only, quote, non-trivial piece, and it's close to trivial. If a is odd, these 2 pieces are certainly even. So let me just write down E and E right here. Okay. Now, notice right here, this piece, an odd number squared is an odd number back. If you multiply by the odd number 3, it's still odd, so I'll put O here. Odd for this. And of course, K is posited to be odd, and so you have plus odd here, right? But this just amounts to an even plus an even, right? An even plus an even number is certainly even. And then an odd number plus an odd number is an even number, okay? So you see, that implies that this is also even. And this is what they call doing a parity. Every number is, there's 2 equivalence classes. Either you're an even or an odd number, right? So you get even right here. So in both cases, for all possible integers, since any integer is either even or odd, we know that since this part is even, we can write this as 16m. Okay, this part is even. You got an 8 out here, so 2 times 8, and it's 16 times some constant. We don't have to write down what the actual constant is. You could do it here, but there's no need to be that specific. Whoops, that's a little messy looking. Okay, so this would be equal to 16m, and we've completed the proof. Okay, at this point we can say we have done this. We started with a squared minus 1, showed that it's equal to 16m, and so right here we can put a QED if you want to. Quantum, or thus we've demonstrated. Or maybe it stands for quite easily done, I'm not sure. But this is the clincher right here. And so we proved what we set out to prove, which was a squared is congruent to 1 mod 16.